In this video, we're going to be looking at a way to figure out a correct Lewis structure almost without exception. So we'll get started with this little chart, and you need to look at the columns that we have in here. Your first column right up here is labeled as the molecular form or the molecule formula, and the second column here, and let's go ahead and give those numbers while we're at it. So we'll call this number 1, and here's our number 2. That's the starting of the Lewis structure with the layout of the atoms. And I'll go ahead and do that step right now for both of these atoms at the same time, or both these molecules at the same time. I'm going to write bromine twice because we're going to have 2 bromine atoms in the formula because of the subscript here. And with phosphorus and chlorine, we have an issue with electronegativity. And our trend for electronegativity looks like this. I'm drawing this down at the bottom, and the electronegativity increases as these arrows show. And my arrows always indicate an increase. So as we go up a column, as we see over here, the column is going to get bigger in electronegativity as we go to the top. The row will get bigger as we go to the right. So as we look at phosphorus, phosphorus would be right about here in the periodic chart, and chlorine would be to its right on the same row. So the origin of my arrows indicates the smallest, where the arrowheads indicate the largest. And so what we have here is phosphorus to the left, and with phosphorus to the left, that means that he's going to be a smaller electronegativity. The atoms with the smallest electronegativity always go in the middle. So we're going to have phosphorus here, and then we have to connect the 3 chlorines. Or we have to put in the 3 chlorines. We'll connect them in the next box. And the chlorines are kind of going like on the 3 of the 4 sides of the phosphorus. So we try to think of the atoms as having 1 to the left, 1 to the right, 1 to the bottom, and 1 to the top. And so those are the 4 sides. Now we go to the third column here, and in the third column we're going to rewrite the bromines like this. This guy only has 2 atoms, and so the bromines are going to go, whoops, I need the R on the bromine. There we go. And now we're going to connect them, and I'm going to do the connecting with blue lines. And now we're going to have to account and find out how many valence electrons we're going to have for this structure. So I'll write my bromine in, and because there's 2 bromines, we have a subscript of 2. And to figure out the valence electrons for 1 bromine, we look to see where bromine is. And since bromine is element number 35, you'll see that it's in column 7, also known as column 17, but column 7 if you use the A numbers in most periodic charts, and those A numbers are going to give you the numbers for the columns that are only representative elements. And they're the guys to the left and the right of the transition elements. So bromine is going to be 7, and we have 2 of them, so that's 2 times 7 is 14 electrons. And because there's only those 2 atoms, that's the total electrons in this Lewis structure. Now, we look over in this box right here, box number 2 for bromine, and we see that blue line there. That blue line represents 2 electrons that are being used in the bond. And because we already put those on the Lewis structure, we're going to subtract those out. And we wind up with a total of 12 that have not been put on the Lewis structure. So I'm going to use a red marker to show you those 12 dots. Now, think of all atoms as having four sides, and I'm going to put electrons on the sides of the bromine that do not have electron pairs. So we can put one here at the top, one pair at the bottom, and one pair at the top, bottom, and left. And that took care of 6 out of the 12. So I have another 6 to give, top, right, and bottom. And that accounts now for all the electrons if I've done that right. And so we have a little checkbox over here at the end to see if we did it right. So here we go. We're going to do number 1 check first. Number 1 check says all have to have 8 except hydrogen, beryllium, and boron. Now, we don't have any of those exceptions, so both of these guys have to have 8. Now, I'm going to go ahead and tap them out. I'm starting with the bromine on the left in column 3. 1, 2, 3, 4, 5, 6. I tap the top, the left, and the bottom. Now I'm going to tap the bonding electrons, and that gives us 2 more, and the total for the first bromine was 6. Now, because these 2 bromines are sharing, that's what those bonding electrons are. They're being shared between the 2 bromines. I'll start with the bonding pair, so that's 2 for the bromine on the right. I went to the top and I tapped there. I went to the right, tapped there, went to the bottom, and tapped there. So my total electrons around the right-hand bromine are also 8, which is what we're trying to get. So I can put a check mark there to say that I've done my bromines correctly and that I have, for check number 1, both of them have 8 electrons. Now I'm going to go to check number 2. My total electrons must be equal to 8. So I look at the bromine on the left. He has 2 on the top, 2 on the left, 2 on the bottom, and 2 to the right of him. That's a total of 8. Now when I'm counting the total electrons, I can only count those bonding electrons once. So that's 8 so far. Now I go to the red dots on the right-hand bromine, and you'll see there's a total of 6 there. So 8 plus 6 is 14, and 14, as you will notice, right there, was the total that we started with. And so total electrons is correct because my starting total is what I actually have in the molecule that I wrote in column number 3 for bromine. So I can put a check mark on number 2. Now let's go ahead and do our Lewis structure for the phosphorus trichloride, and we'll have chlorine on the left, chlorine on the right, chlorine on the bottom, and phosphorus in the middle. Now I'm going to take my blue pen and let's connect them. Chlorine connects with phosphorus on the left, to phosphorus to the chlorine on the left, phosphorus to the chlorine on the right, and phosphorus to the chlorine below. Now each of those lines represents 2 electrons, and those are bonding electrons, so let's not forget that. Now we're going to go and figure out column number 4, which we figured out for the bromine already. We're going to do that now for the phosphorus trichloride. So phosphorus is sitting there. There's only one of him. If you look on the periodic chart, you'll see that he's in column 5 or 15, depending on which chart you're looking at, which means he has 5 valence electrons. So it's 5 times 1, or 5. Now we're going to do chlorine. Chlorine, there's 3 of these guys, so I just put a subscript there. And chlorine, if you look on the periodic chart, is in column 17, or 7, depending on your chart. And that means he has 7 valence electrons. But there's 3 of him. So we're going to have 7 times 3, or 21. And so our total electrons are going to be 26. Now, we have to account for those blue electrons. Each line is 2 electrons, so I'm going to have to count 2, 4, 6, those blue lines that are touching phosphorus. And so I'm going to subtract those 6 electrons, and that leaves me with 20 to pass out. Now I'm going to pass them out with red electrons, or red colored dots, and we'll start with the chlorine on the left side. And we're in column 3 right now. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We have just passed out all 20 electrons. The good news is that it looks like the Lewis structure might be correct. So let's go ahead and do our checks. I'm looking at number 1, which says we have all have 8, that is, and that is looking at the chlorines. Each chlorine you'll see has red dots around them that total 6, plus the blue that touches him, and that's another 2 for a total of 8 on each chlorine. So just to work that number out, we have 8 for each chlorine times 3 is equal to 24. And the blue lines are also counted for the phosphorus, but we can't count them twice. So we have 24 until we count the red dots that are on phosphorus. Those are the guys that aren't shared. And there's 2 of those. So if I add 2 more, I get a total of 26. And 26 was the number that I started out with. So we checked number 1. They all had 8. All the chlorines had 8. Oh, we got to look at one more thing. Does phosphorus have 8? Phosphorus has 3 blue lines for a total of 6. It's 2 electrons for each blue line. And then we have the 2 red. So that's 8. So we can check this number 1 off. We did that right. And now let's do number 2. And that was the total that I just got over here. 26 equaled the 26 over here. And that baby checks out. The total electrons are correct, because our total that we started with are the total that we have on our final structure. And that is how you're going to do your Lewis structures. I hope this helps you. Bye-bye.